Lesson 5.2, Polynomials. First off, let's define what a polynomial is. A polynomial is an expression. Actually, let's define what makes something not a polynomial. An expression is not a polynomial if it has any of the following. Fractional exponents, in other words, exponents that are fractions. Square roots of variables, so in other words, a variable underneath a root sign. A numerator that has negative exponents, or the top part of a fraction that has negative exponents on the variables, or in the denominator, which is the bottom of a fraction, having a positive exponent of a variable. Okay, first thing we're going to look at is adding and subtracting polynomials, but before we do that, we'll get into the degree of a polynomial. The degree of a polynomial is the highest exponent on any term in polynomial, or if there's more than one variable in a term, it's the combined exponents. Yes, you add them if there is more than one variable. So we'll look at these first two examples here, determine whether each expression is a polynomial or not, and then if it is a polynomial, we need to state the degree of the polynomial. So this first one, we have c to the fourth minus 4 times the square root c plus 18. Again, if we have square roots of variables, which we have right here, then this would be not a polynomial. So this first one is not a polynomial. Okay, if we go to the second one, letter B, negative 16 p to the fifth plus 3/4 p squared q to the seventh. The first term is fine. We have a variable to a positive exponent. We have this fraction 3/4. Now we said there can't be fractional exponents, but you can have a coefficient, which is what's in front of the variables, be a fraction. Okay, and then p squared, q to the seventh, they're both positive exponents. So yes, this is a polynomial. And we need to find the degree. The degree, we look at the degree of each term. So if you look at the exponent on this first term, it is 5. So that term has degree 5. If we look at the exponents on the second term, okay, this whole second term here, but looking at the variable, notice there's more than one variable. It's p squared q to the seventh. So we need to combine those exponents to find the degree of this term. So in other words, we add them, 2 plus 7. So that term has degree 9. So the degree of the polynomial then is you take the term that has the largest degree. So the degree of this polynomial would be 9, because 9 is bigger than 5. Okay? So now we're going to go into simplifying. Okay? If you notice here on this example, I have a trinomial and I'm subtracting another trinomial. Okay? If you have a subtraction sign right here, you need to distribute the opposite sign or the subtraction sign to what follows it in parentheses. There is no opposite sign in front of the first trinomial, so you can just drop off parentheses. So you're going to have 2a cubed plus 5a minus 7. Okay, those signs stay the same on those terms, but now you distribute your opposite sign, so you're going to have minus a cubed, and then it'll change to plus 3a and minus 2. So we get a list of terms there. We have 6 of them. Now we want to combine like terms. So I'm going to combine my a cubed terms. So 2a cubed minus 1a cubed is a cubed, or 1a cubed. So I've taken care of those two terms. Now I want to combine my a terms. 5a plus 3a, they're both positive, would be plus 8a, 5 plus 3. So combining these two terms. And then I can combine my constants, or my number terms. Negative 7 minus 2 would be negative 9. So we end up with a cubed plus 8a minus 9 for the answer on that particular one. If this would have been a plus sign here, then no signs change in this second one. And you keep the same signs and then just combine like terms, drop parentheses off, and combine like terms. All right, then we'll get into multiplying polynomials. Okay, first of all, if we multiply a monomial, okay, a single term multiplied by something with more than one term, in this case a trinomial, all it is the distributive property. Okay, you just distribute the monomial. So we're going to distribute negative y here. So I get negative 4y to the second, y to the first time, y to the third. Y times y squared is y to the third. So that is, let me erase that and rewrite that. That's negative 4y cubed. Add the exponents there. Distributing a negative will change the sign on the next term. Negative times positive is negative. Y times 2y is 2y squared. And then distributing the negative y to the negative 3 changes that to a plus 3y. And that is as far as you can go. None of those terms are like terms. So there's what we have. If you look at the next one here, again, it's a monomial, a single term. We're going to distribute that to all three terms. So 2x times 7x squared is 14x to the third. I take x to the first times x squared, add the exponents there. I'm distributing a positive, so positive 2 times negative 3 is negative 6x squared. X times x, there is x squared. And then 2x times 5 would be plus 10x. And that's as far as you can go. None of those are like terms. So if you multiply a monomial times whether it's a binomial or trinomial or four-term polynomial, you distribute if you have a monomial outside of it. Okay, multiplying two binomials, you use what's called the FOIL method. Remember, FOIL, that's the acronym first, outside, inside, last. So I'm going to multiply my first terms, which would be 2p, the first term in the first one, 2p times the first term in the second one, which is 4p. So it's 8p squared. Then I do my outside terms, or outer terms, which would be 2p times positive 1, which is plus 2p. Then I do my inner terms, or inside terms, which would be positive 3 times 4p, which is plus 12p. And then I do my last terms. That's what the L stands for. So I do positive 3 times positive 1 multiply. So it's 3, not 4 there. Okay, so there's what you do when you do the FOIL. And now you combine like terms. These two terms right here are like terms. So we're going to combine them. So I have 8p squared. Positive 2p plus 12p is plus 14p. And then plus 3. And that's as far as you can go, so we end up with a trinomial answer right there. Okay? If we FOIL over here, again, it's a binomial times a binomial. Anytime it's a bi times a bi, you do the FOIL method. Or you distribute twice, would be another way of thinking of it. So I'm going to do 5x times 5x, which is 25x squared. Okay? I'm going to do then my outside terms, which would be 5x times negative 4w, which is negative 20 wx or xw. You can write it either way. Then I'm going to do my inside terms, which would be the two on the inside here. Positive times positive would be plus 20 wx. And then I'm going to do my last terms, which are positive 4w times negative 4w, which is negative 16w squared. Okay? What happens here is these two are like terms because they're both wx. We have minus 20wx plus 20wx. They are opposites. When you add opposites, those terms drop out. So I end up with 25x squared minus 16w squared, which are not like terms, can't combine. So you're left with a binomial or two-term answer. Okay? Here is, I really want to put a star by this problem. This will come up a lot. In this case, it's with algebraic things, but it does apply to other things in algebra too. When you have a binomial squared, a common mistake is when there's addition or subtraction inside there, is students think you can just square each term. Okay? They think, oh, you can square 2x, so 2x times 2x is 4x squared. And then you can square negative 9, so it's plus 81. Now, that is not the correct answer. I will tell you those are a couple of the terms on the answer, but anytime you have a binomial squared, you must write it out, because to square something means to multiply it by itself. So write it out, multiplying 2x minus 9 times 2x minus 9, okay, and then FOIL. So here's what we want to do. 2x times 2x is 4x squared. 2x times negative 9 is negative 18x. Okay, and then I do negative 9 times 2x for my inside terms. That's also negative 18x. And then I do my last terms, which are negative 9 times negative 9, which would be a positive 81. Okay? Combine like terms. These two in the middle here are like terms. So we're going to combine them. And I get 4x squared minus 36x plus 81. Okay? Notice, there's your answer. If you did what I was talking about incorrectly, you get the 4x squared and the 81, but you missed the middle term. You must write out a binomial if it's squared. Must write it out twice, multiply it by itself, or you're going to miss the middle term. Very, very important and a common mistake that we see. Okay, last thing here is we're going to multiply a binomial times a trinomial. Okay, and basically what you do is you distribute each term from the binomial to the terms from the trinomial. In this case, the binomial is second, so I'm going to have a times a squared, which is a cubed, a times 3a, which is 3a squared, a times negative 4, which is negative 4a. And now I'm going to just keep going here, but now I'm going to distribute my 2 to each of those terms as well. So I'm going to do 2 times a squared, which is plus 2a squared, 2 times 3a, which is 6a, and then 2 times negative 4, which is negative 8. So I end up with 6 terms there, and now I combine like terms. I only have one a cubed term, so it's a cubed. I'm going to cross that one off. But I'm going to combine my a squared terms together. Both are positive. 3 plus 2 is 5, so I get plus 5a squared. Negative 4a plus 6a, so negative 4 plus 6 is positive 2a. And then I just have the negative 8 for my constant, so I end up with a 4-term answer right there. Okay, let's jump over to the next problem. We're going to distribute our x to all 3 terms. Okay, so if I do that, here's what I get. I get x cubed, okay, and then minus 3x squared y, and then x times 2y squared would be plus 2xy squared. And I'm going to continue writing in the next line here. I'm going to now distribute my y to all 3 terms. So I'm going to get plus, well, I'll start up here, so I get plus x squared y. And then if I distribute y to my next term of negative 3xy, I get negative 3xy squared. And then if I distribute my y to the 2y squared, I get plus 2y cubed. Okay, now if I look at like terms there, I've only got one term that is x cubed. So I'm going to write that down first. Okay, this term right here is x squared y. That's going to get combined with this term right here, which is 1x squared y. So negative 3x squared y plus 1x squared y is negative 2x squared y. Let's rewrite that. So negative 2x squared y. Okay, so I've taken up those 2 terms. Now notice these terms are xy squared, which are not the same as x squared y, but I'm going to do this term and this term together. So 2 minus 3, or 2 plus negative 3, is negative 1 xy squared. And you could put the negative 1 on there. I'll leave it off right now. I need the negative sign, but you don't have to put the 1 there. You can. And then you just have, so we've taken care of those 2, and then I just have plus 2y squared, or 2y cubed, excuse me.